This is the second day of normal curves. The big question arises, what do we do if the value we seek does not fall directly on a standard deviation? This happens quite frequently in real life. The problems we did for homework last night took the skier on a downhill course with a mean time of 4.3 minutes and a standard deviation of 0.4 minutes. So what if I want to find the idea that it took 4 minutes or less? What part of the population took 4 minutes or less to do the downhill course? This creates a problem for us because it does not fall exactly at a standard deviation. So the first step of that is learning how to deal with a standard normal curve. So we are, instead of dealing with this table that has all the standard deviations on it, we're still going to use this to set up our guesses. But to do the second part of the homework assignment, which was part 2, we are going to use the standard normal table that we received in class, and it's also available as a download on the reference page of the website for our class. The problem I'm going to do for us is going to be problem F. I'll demonstrate that problem, and then you should be able to try the other ones. So we are looking for a z-score between negative 2.5 and negative 1. The probability of negative 2.5 is less than the z-score is less than negative 1. Let me double check that. Okay, so the first thing we need to keep in mind is that on our standard normal curve, we have a mean of 0 and a standard deviation of 1, and we should list that under our curve and put our standard deviations out. So we can now take these values, draw the lines at approximately where that would be, negative 2.5 standard deviations and negative 1 standard deviation, and I'm looking for all the area in between here. The first thing I would like you to do is use the pages we colored to make an informal guess about what the answer might be to our question. So I am thinking that this looks an awful lot like 1 standard deviation and below. And if you refer to this table, 1 standard deviation and below is approximately 16%. So my guess is going to be that I am going to get a number just under 16% because I am missing the tail area right there. So what we are going to do is look up in our big standard normal table how much area is below negative 1 and how much area is below negative 2.5, and then we'll take those two values and subtract them to get the striped area. You need to understand that the table we're going to go to uses z-scores with 2 decimal places. So I am in fact going to look up negative 2.50 and negative 1. The negatives are on the front page of the table. So negative 2.5 is this value right here. And O, the second decimal place, that puts together negative 2.50, and I'm looking at 0062. So coming back to my problem, I know that from here down is 0.0062. Now I'll look up negative 1. We should know that that's 16% from our empirical rule that we have to remember. But let's just double check because that's just an approximation. So if I go down to negative 1.00, it's this value right here, and it's awful close to 16%. It's actually 0.1587. So that's what this is, 0.1587. So the answer to the striped area is going to be 0.1587 minus 0.0062. And when you subtract those values, we will get 2.1525. That is the answer, and it does match our guess of 16%.